All right, welcome to The Explainer. Today, we're going to look at something we feel every single second of our lives, but maybe don't think about too much: atmospheric pressure. We're going to dive into a pretty provocative theory from one author who claims the sky isn't falling, well, because it doesn't actually weigh anything to begin with. So, according to the standard model of physics, that number you see, 11.2 tons, that's supposedly the weight of the air pressing down on every single square meter of the Earth. To put that in perspective, that's kind of like having two full-grown elephants standing on your doormat.
And this brings up that classic question everybody asks at some point. If you've got all that weight just sitting on your head and shoulders, why aren't we all just pancakes?
Now, the standard answer, the one you'll find from places like NASA, it goes something like this. Don't worry, the air inside your body is pushing out with the same force that the air outside is pushing in. It all balances out. Sounds simple enough, right?
Well, hold on. The author of the theory we're looking at says this explanation is just fundamentally wrong. He points out that, our bodies are mostly water, not air. And if the air in our lungs was really the only thing holding back tons of pressure, then, logically, every time you breathe out, you'd basically implode.
So this apparent contradiction, it's really just the first of several paradoxes the author brings up. And he argues that all of these weird problems pop up because we're confusing atmospheric pressure with simple downward weight.
For example, think about a plain old bathroom scale. It's got a surface area of about 1 square foot. So if the standard model is right, it should be registering something like a ton of force from all the air sitting on top of it. But when you look at it, it reads 0. Why?
Now the standard comeback here is that, the air underneath the scale is pushing up, and that cancels out the weight from above. But the author poses a pretty clever counter-question. If the air under a tiny scale can support an 11-ton column of atmosphere, then why can't that same force lift a person off the ground with no problem at all? And here's another little puzzle he presents. He calculates that there are about 270 pounds of air pressing down on your hand. Mainstream physics says your body just equalizes this. Okay. But if you put that same hand on a scale, the scale shows 0. So the author asks, why is your hand supposedly supporting hundreds of pounds, but the scale right underneath it feels nothing?
This whole line of thinking leads to what he calls the 800-pound arm paradox. I mean, think about it. If your outstretched arm is constantly fighting off hundreds of pounds of air pressure just to stay level, then in a vacuum, or even way up on a mountain where the pressure is lower, you should be a superhero, right? You should be able to lift incredible weights. But that's not what happens. So, how does the author propose we solve all these paradoxes? He argues they all come from one massive, fundamental misunderstanding. This idea that atmospheric pressure is the same thing as weight.
And this is a really crucial point. Weight is simple. It's a force vector that pulls straight down. It's a one-way street. But pressure in a gas, that's a whole different animal. It pushes in all directions equally, up, down, sideways, you name it. The source claims that conventional physics is making a huge mistake by measuring pressure and calling it weight. It's kind of like trying to measure how tall you are with a thermometer.
Now, the author takes this claim even one step further. He alleges that the scientific community actually knows the atmosphere should have weight because of gravity, but they can't figure out why it doesn't show up on a scale. And so he says they've created all these confusing explanations to paper over a huge hole in the standard model.
So, what's the missing piece? According to this author, it's a totally new force of nature that he calls the charge field. He describes it as this constant stream of photons shooting out from the Earth itself, creating this universal, repulsive force that pushes everything up just a tiny bit, working in direct opposition to gravity.
And this new charge field is the absolute key to everything. The author uses it to build a mathematical model that, he says, explains exactly why the atmosphere would be, for all intents and purposes, completely weightless.
To do this, he first wants us to imagine the atmosphere like a giant, super wide, kind of leaky container. So the floor is the Earth's surface. The lid is way up there, the ionosphere, about 50 kilometers up. And the sidewalls? Well, they stretch out horizontally for about 1,600 kilometers.
So what you've got is a gas trapped in an incredibly wide, flat container. Because of this shape, the author argues that any given air molecule has way more room to move sideways than it does up or down. To be precise, he calculates it has 1,024 times more freedom to move sideways than vertically.
And here's how the math supposedly plays out in his model. He starts with the standard force of gravity, 9.78, but then he divides it by that massive lateral freedom factor, that 1,024 number. And the result is this tiny, almost non-existent, effective downward force for the atmosphere.
And here it is. This is the core of his entire theory. That tiny downward force he just calculated is a near-perfect match for the upward force of his proposed charge field. The two forces, according to his math, almost completely cancel each other out. And what's the result? An atmosphere that is effectively weightless.
Okay, but this leaves one last really big question. If the atmosphere has no weight, then what causes the pressure that we can clearly measure? You know, the pressure that gets lower when you climb a mountain. What is that?
The author's answer is surprisingly simple. He says it's not about weight at all. It's all about density. He uses a version of the ideal gas law to show that pressure is just directly related to density. Where the air is denser, the pressure is higher. Simple as that.
So why is the air denser down here and near the surface? Well, because, he claims, this is where it comes from. The Earth itself is exhaling its atmosphere. Oxygen comes from plants and oceans, nitrogen from the crust. It's kind of like your breath. It's densest right in front of your mouth. So, the atmosphere is densest at its source, the surface of the Earth.
Okay, so let's just boil this all down to the crucial takeaway. According to this theory, the atmosphere is effectively weightless because this proposed repulsive charge field pushing up from the Earth perfectly balances the atmosphere's tiny little downward force, a force that was already massively reduced by all its sideways freedom.
So, we've just walked through one author's very unconventional and, let's be clear, unproven challenge to a really foundational idea. Now, whether you find it compelling or not, it's a fascinating exercise in just questioning our basic assumptions. And it kind of makes you wonder, doesn't it? What's the value in re-examining the ideas we all just take for granted?